Okay, good morning, everyone. How are all of you today? Good? I'm appreciating the enthusiasm from like the 4 people that responded. So, today we're going to continue on our conversation concerning data and displays. Before we do that, let's take a moment and let's recall what we talked about last class. What did we talk about last class? Histograms. Excellent. And what was it again? Yeah. And box plots. So, what are both histograms and box plots? What kind of data do they look at?
Frequency?
What do you mean? Frequency? What do you mean,
like how often the percentage of the served observations that have a particular data, like
Sure. So like that's what we see on those percents, or maybe a percent of observations in this data go in this range or whatever it is. Those are what we see on like the axes, or what we might be measuring. Right. And sometimes too, we can see frequency as well on a histogram. Right. How many times it happens. Not necessarily the percent of observations it represents.
Right.
But that's not necessarily type of data. Frequency doesn't say type of data. What do we mean by type of data? We talked about 2 different kinds of data back before.
Quantitative.
Quantitative. What is quantitative data? Absolutely. Tell me more.
I know your name without figuring out the percent, and I won't say it's not good. No, I'm so Michael. I asked you that last time, figured it out. Yeah, it's all came out for that. Again, I'm not good at that.
Yeah, you can pass it around. Just grab it and pass it around. The sign-in sheet. Yep. So, quantitative data, as Michael points out, is numbers, related to numbers. And so we had 2 different kinds of displays we talked about. Histograms. And box plots. Now, when I look at a histogram, though, it doesn't look like it's quantitative. It looks like it's categorical. This is a category, this is a category, this is a category. What makes it numerical in nature? What makes it quantitative in nature? What? Exactly. Anisha is absolutely right. So we might have a range here of 28 to 22, and then 22 to 24, and 24 to 26. In other words, we take data that is inherently quantitative and we just put it into categories. We create categories that the data can go into. Note in these cases, each distance here is the same. This reflects 2 points, 2 points, 2 points, with different starting points, right? Each bin, we say each bin is the same. What goes on in a box plot?
Quartiles.
Yeah, the quartiles. Tell me more.
You see how many or the range of each. The first quarter, 25%. The first 25% of the information. The median of the information. The third quartile and the fourth quartile.
Exactly. And all the way. I'm sorry, Q3 and Q4. Or the minimum, the median, the maximum, and then the first and third quartiles. Absolutely. Now, appreciate this, the symmetry between these two. Left and word, the symmetry. So, what percent of the observations are here? 25%. What percent are here? 25. What percent are here? And what percent are here? But always 25%. But is this range from Q0 to Q1 always going to be the same as the range from Q1 to Q2? No. That's rarely it would be. It could be, but rarely would it be. So while the number of observations in each group is constant, the range varies. Or the range within each group. Here it's the opposite. Here the range is constant. This reflects 2 points, this reflects 2 points, this reflects 2 points, but within each of these symmetric groups, there can be 50% of observations, there can be like 1% of observations. In this case, that might be, I don't know, 20% on the scale here. So here, the number of observations within each grouping can change, within each bin changes, the percent of observations changes, even if the bin size is the same. While here, the bin size is not constant, but the number of percent of observations within each bin is uniform. Any questions on that? Great, so that was a big thing we talked about. But sometimes you get data that is not quantitative in nature. Sometimes you get, what's the other kind of data?
Qualitative.
Categorical. It's categorical in nature. What's a categorical kind of variable? Is Patrick here? Obviously learn more names. Patrick, excellent. So what is an example of a categorical variable?
Pets.
Pets. What do you mean?
Is that a categorical?
Well, I don't know. How are you saying number of pets?
Like dogs, cats.
Oh, so maybe like, it's tricky, right? It could be the number of, do you have a dog in the house? Or what is your preferred pet? Right? Dog, cat, bird, salamander, beluga whale. Right? Not a great pet. But, some people like it. Excellent. Any other examples of categorical data? Name again is? Oh, I already asked you that earlier. Robiano.
You say that race sensitive.
Yeah, excellent. Right. So race, there's lots of different categories for that. Gender, fewer categories of that, but still it's a categorical data. We never want to say one is more than or smaller than the other, just like with numerical, with quantitative data, that makes sense. One observation can be twice as much large as the other one, but it doesn't make sense that there's no natural relationship between Hispanic and African American. That there's no order, natural order there. So typically then, if we were to graph categorical data, we were to display it. Well, here we have to have a precise order, 20 to 25%, 20, these are increasing, these categories. In a typical categorical data set, the order doesn't really matter. If people do anything, they might do an alphabetical. If there's any sort of alphabetical order you can put in. But other than that, it doesn't really matter. Any questions? So, what's an example of a display that uses categorical data? Pie chart. Pie chart's the classic one. Let's go pie chart. There's another one too. It's another pie chart. Bar. So, it's sort of tempting to give you a definition of pie chart. I guess I feel like I have to, right? Just in case you're not familiar with it. So one of the nice things about a pie chart, they're very, very tight. And it's just simply a circle divvied up into categories. A circle of wedges. Each wedge is a category. And size of the wedge equals what? Yep, exactly, percent of total. I mean, technically you could say the arc, because then that would be a linear measurement rather than a two-dimensional measurement, which is area, and it's one of the weird things about pie charts. Now, what is a bar chart? I didn't really draw this correctly. It's like a histogram, absolutely. Except, what's the difference between a histogram and a bar chart?
Does that range?
Exactly, it doesn't have ranges. Each one of these ranges is instead a category. Right. A, B, C, whatever those categories are. It can be a percent, like percent of households that have aardvarks, percent of households that have baboons, percent of households that have cats. Or it could be a frequency, number of households that have aardvarks, number of households that have baboons, number of households that have cats. I would do a D one, but I can't think of a good D animal. Maybe dingoes. Oh, sure, dogs. I always forget about dogs. I'm a cat person. Yeah, I know. So, one of the nice things about bar charts is that they're a little bit more precise, and you can see that with pie charts can be a little deceptive. Pie charts can be a little hard to understand. So, here's an example. Down here with my light. In pie chart B, which is bigger, red or blue?
Blue.
Blue. Are you certain? Yes. Clearly blue is bigger, right? Clearly blue is bigger. Well, here is a bar chart of exactly the same thing. You said blue is bigger than red? Nope. They are exactly the same size. Right. Easily you can see blue is the same size as red. Pie charts are kind of weird because you can't, again, you're really looking at area. And area, comparing areas, especially areas of like triangle things, they're not even triangles because they have this arc, they have a curve to them. It's tricky sometimes. And now too, you might think that blue is the same size as green, but it turns out actually green's a little smaller. Red's a little bigger. But glancing at B, you're like, all the same size. Right? No, they're slightly different, right? And you really only see that easiest when you look at the bar chart. So on one hand, bar charts are good because they can more easily see these little differences, right? Because you can more easily compare these vertical lines. So what we care about is just one dimension rather than the two of the area. At the same time, one of the nice things about pie charts is they're very dense. A bar chart can get really unwieldy and really big, especially when you have lots of different categories, because then each one has to go out larger and larger as you have the individual slot for it. If we had 10 categories, it would have to go all the way out here. But a pie chart of 10 categories still takes up the same amount of space. That said, a pie chart with a lot of categories, also hard to read. Here is data on the US federal budget. This is where the money goes. Now, they solve a little bit of the issue with seeing how big things is when they add numbers. I don't know how easy it is to see. I might want to choose a different one. US federal budget. Images, here we go. This one's better. This one has a better resolution on it. But it's like, if one has fewer categories, but it's like, it's a little hard to tell all these individual ones. I guess they give us some data, some labels, I should say. But it gets really clunky, right? It gets really awkward. I should put in all these labels. So that's housing and community right here, and that's international affairs, And that's education. Wait, no, that's education. Right, that's not education. Look, draw the line. Right, it gets crowded. It gets clunky. So in some ways, it has some of the same constraints as a bar chart, arguably less pronounced. However, we can do a simplified one too. Rather than taking all those individual categories, especially ones that you saw. This was like, you see this, and you just want to like, pull out your own eyes when you look at it. Like, what is that one? I don't even know. So they take a lot of these, and then this much better one, they condense it. We have non-defense discretionary over here. We have other mandatory spending. The net is, because sometimes there's income as well in some of these. What percent of Social Security? What percent of the budget is Social Security? 24, right? But even if that number wasn't there, you would say, yeah, it's about 25. It takes up a quarter. This is 25 too, healthcare. Huge chunk goes to this, so half goes to that. Any questions on this? They're both useful in different ways. It really depends on how much space you have and how much detail you want. Okay. Let's see. What else? Oh! I kind of like bar charts more. I mean, I get really kind of annoyed at pie charts because I guess I like that they're round. I think that's one of the big advantages. They're round. That looks pretty. But bar charts are more useful in general. Again, you have that distance issue, but they are more useful in general, especially when you have multiple categories, multiple categorical variables that you care about. Not merely multiple categories, not merely we have lots of different kinds of spending, but within each group, maybe in a different one, maybe an additional issue. Like if you imagine a table, we might have an issue of ethnicity or race on one category, and other categories maybe gender. So we have male, female, and I'm not sure what the political correct term is for like the mixed gender identity or non-binary gender identity. And so then you can see how many are in each group. Right? We have multiple categories. Tables, though, are not really, I mean, they're in a lot of ways very useful displays because they give you the raw numbers, but they don't intuitively show things like a display does. So we turn to 100% stack bar. In a 100% stack bar, we have two kinds of different categories we work with. On our x-axis, is one categorical variable. Just like before, just like here. But then, within each bar, oh, as I should say, all bars are 100%. So all of these then would go all the way up to 100. And you might be like, what the hell's the point of that? They're all the same. But in a 100% stack bar, you then divvy up that 100% in kind of like a pie chart. And then each size determines the percent of a different category. Different categorical variable. sound for my phone. I apologize. I hate people like me. It keeps going off. I'm like, I'm sure people will stop trying to contact me. And then, of course, it doesn't actually happen. So we're just gonna... Well, within each category on the x-axis. So, to illustrate, here's a standard categorical data, a bar chart. These are the grades that I assigned back in 2014, I want to say. A's, B's, C's, D's, and F's. We skipped B for some reason. And then I threw in also the exact number. But, of course, I have lots of different classes. I teach 5 classes every semester. So, what if we're curious, did one section maybe have a harder time than the other? So here is a version of that as a 100% stacked bar. Just like before, all of them go up to 100%. Because here are, say, the F's or the D's. We say what percent of, say, C's went to each class. What percent of B's went to each class? So, what percent of B's went to macro at 10 a.m.? 23%. Yeah, about 23% or 25%, roughly, right? You see that. What percent of B's went to macro at 11 a.m.? What? How do you get 16%? So I'm looking for the red one. So what percent of B's went to the red one? How big is this? I want to say 16. I like to narrow it down to 16. Yeah, I see it more. 15, but sure, 16-ish. How do you get that?
Because not because it's between 30 and 40.
Mm-hmm.
I was assuming it's
Yeah.
It's an estimate.
Yeah, it's an estimate, right? And that's something you run into these stacked bars. Because this is a cumulative amount, right, with a running total, you have to then, if you want to figure out any one particular category, you sort of have to do a little mental subtraction. Well, this is about, this is right at 60, this is right at maybe, I don't know, 42, so 60 minus 42, 18, this is 18% roughly. It's a little annoying, it's a little imprecise, but you do get some interesting amounts. Like you immediately can tell me which class got the highest, where did the largest share of my C's go to? Yeah, 11 a.m. macro, right? Immediately you see that, right? This is the largest one. By the way, if you're curious, that 11 a.m. macro and micro at 11 a.m., the difference is one is Monday, Wednesday, Friday, and one is Tuesday, Thursday. So that's how I was in 2 different places at once. So I was not actually in 2 places at once. Which class do you think did the worst? Macro 1 p.m. Why? Well, it certainly has the most F's. And most of the F's went to that. That's true. But what else do you notice about 11 a.m. macro?
They have the most A's.
I'm sorry, at 1 p.m. macro, I mean. They have the most A's, yeah. A plurality of the A's went to them, too. So, which then is the bigger issue? Like, so does that mean that macro is the best class at one, or macro is the worst at one? It's like an unusually large number of people failed that course. Any questions on that? Well, we can somewhat solve that by breaking it down even more. Because, as noted, we don't know the frequency. We don't know the frequency. So what you can do rather than a 100% stacked bar is you can do sort of a nested bar. So within the A's, you can have 5 individual bars. And that tells you how many A's went to this class, how many A's went to this class, not just the percent. And then you can do the same thing with B's and C's and D's and F's. How many individual vertical bars will you get if you do that?
5 in each.
Well, you have 5 categories here on the x-axis, and then you have 5 categories within each category. So 5 times 5 is 25. 25 bars. Technically, you have 23, because note that red does not appear in this one at all. And so we only have 4 here. 1, 2, 3, 4. We also only have 4 here. 1, 2, 3, 4. There was one class that didn't get any F's. I think that was macro at 10 a.m. They didn't get any F's. So technically, we're going to have 23 bars. But we will still need the space for those 2 missing bars, because you have to indicate that those classes have 0. So when you take this same data and you make a nested bar chart, this is what you get. Here's my missing ones, or the ones that are at 0, I should say. And it's like, it's a bit busier, right? We have to throw in all these things. And I guess it's workable. At 25, you can sort of see it. But imagine if I taught 6 classes. Now I'm adding an additional 5, right? Immediately, right off the bat. Imagine if there were like 5 and then 10 categories. So there's 50 categories. There's 50 bars. Right? It can get unwieldy rather quickly. But you also get more information here. So are you still willing to say that macro at 1 p.m. was the worst performing class? No, why not?
They have a lot more A's and B's compared to F's.
Yeah, there was some, like, I don't know, for some reason, you know, we had 4 F's, that's half the F's, right? We saw earlier, that's a total of 8 F's that I gave out that semester. See that here? There's my 8 F's. So they got half the F's, but, you know, there's not many F's compared to A's. So arguably, rather than being the worst class, you can argue macro was the best one. They got a lot of A's. More A's than any one class did. What do you think is the worst class? Micro 11 a.m. had a hard time. A lot of C's in that class. And they had some F's. Macro at 10 a.m., I guess, macro at 11 a.m. kind of had some trouble too, with a fair number of C's. So, you know, it's debatable. You can take averages if you want. But just as an idea, right, this obviously gives you more information. Most notably, it gives you the frequency as well, which 100% stacked bar can never do. But it also takes up more room. It's a bit busier. Any questions? Okay. Last one we're going to do, scatterplots. So we're going to do scatterplots, and then I'm going to show you how to make a lot of this stuff in Excel. I don't want to spend too much time on the definition. So I want you to actually define it for me, if you could, because you probably already know what it is. So you should be able to tell me, what is a scatter plot? Like, could you give me an example, or just give me a general definition?
It's got a y-axis and an x-axis, just like a normal, like a bar graph or a histogram would, but it's just got like dots kind of scattered all randomly, and
Maybe in some sort of plot.
and each dot like has a representative x value and y value.
Yeah, exactly. Indicating. So notably, the axes are variables. Both axes are variables. Rather, before only one of them was. Right, the other one was maybe frequency or percent. And scatter plot, both axes are variables. And each observation is a dot on the plot, based on the value it has for one variable and the value it has for the other variable. Notably, this would have to be quantitative data, because you're actually looking at numbers. Once looking back to quantitative data. So, what would two variables want to curious about?
Wait.
Weight and height. Mathematicians might get annoyed that I put weight over here and height over here, because arguably height causes weight and weight doesn't cause height, so you typically put the independent variable on the x-axis. But in a scatter plot, it doesn't really matter. You're not ever claiming causation in a scatter plot. And it might look like this. So this individual has a particular height and a particular weight. This individual has a particular height, particular weight. This one has a particular height, particular weight. This one, and so forth. And it's helpful to be able to do this because you get an idea on the relationship between the two. Notably, these are, as we will talk about later, positively correlated. They tend to move together. If you want to do this, I recommend you go to gapminder.org. And if you go to gapminder.org, I believe if you go to like it's Gapminder Tools takes you there. Yeah, Gapminder Tools takes you there. They have data right here. So, and it's easily to understand scatter plots. They do something slightly different in here. They make the size of the dot, each one of these is a country, they make the size of that dot proportional to their population. So you can easily see, say, where China and India are. And by the way, this one, do we know what this green one is? United States. So, by the way, if you're curious as well, for your memo data sets, I use, one of the options is country level data, and have a whole bunch of variables for country level data. And I got all that data from here, because Gapminder makes it really easy to find the data. You just have to go to back. Just go to this data section, and then it has a list of all this data by country. You see there's 519 entries. I don't have all of them there, but if you click on any of these Excel things, you can get the actual data. So it's super easy. It was super fun and relatively straightforward to make. You always get weird things like you have to match the data correctly. So sometimes sometimes data calls like North Korea, they call it North Korea. Sometimes they call it Korea, Democratic Republic. Sometimes they call it Democratic Republic. So you have to match it all. But it was much easier than it would have been 20 years ago. And note too, we have a nice relationship between here is life expectancy here, country's life expectancy. Over here we have country's income. And what's fun too is then you see in the watermark, it gives you the year. You can rewind it, and you can see the world back in 1800, a much smaller population then, a much poorer population then, a much deadlier population then. Life expectancy was a lot lower. And if you hit that play button, you can see the world change as we go from year to year, as countries begin to get wealthier and get healthier very slowly. Sometimes there's a little famine, that's always bad. But we start to see slowly in around the 1900s, people really start taking off. 1800s, 1900s. Then, of course, there's World War I, so you're going to see a drop. There it was. And then we keep expanding. Roaring 20s, 30s. Oh, World War II. That was bad. But now things are really taking off. Life expectancy jutting out. Oh, here comes China. It's going to pace itself across for income as it grows, wealthier and wealthier. And now we have a whole new world. It's really fun to play with. And of course, too, and I encourage you to do this and to play with this if you want to use your memo data sets with the country level data, because it will easily show you these sort of relationships. You can click any of these axes and you can select a different variable. So if we go under maybe, I don't know, education, and maybe we can find, I don't know, mean years of school, and I don't know, general one. Here's been 25 and older. Now we have a completely different data. This is 2009, obviously, so it's going to be based on the most recent information they have. But if you mouse over anything, too, you get the individual data. China, 7.7 with 85-70 income. Let's go back to life expectancy. Any questions so far? Okay. One thing, though, that becomes crucial to understand is your axes, because these axes are slightly different, and you don't necessarily notice them. Obviously, one is life expectancy, and one is income, but they're different in a more fundamental way than just their different variables. What's the difference between? No? Yeah. Oh, you weren't raising your hand? Oh, okay. Do you want to try anyway?
I'm sorry.
Question is, what's the main distinction between this axis and this axis?
Values.
Yeah, values, but also think of the rate of change. So we got 10, 20, 30, 40, 50, 60. Yeah. The difference between 500 and 1,000 is, of course, 500, but the difference between 8,000 and 16,000 is not 500. It's, as you noted, it's doubles. So these are two different scales, one of which is called the linear scale, and one of which is called the logarithmic or log scale. Linear scale. In a linear scale, you pick a constant value, in this case 10, and then the next unit that is equal distance away is the original plus that constant value. A constant value is added to the previous unit. To get the new unit. How would you think you want to define a logarithmic or log scale?
Multiply.
Multiply, right? The only difference is multiply. Constant value is multiplied by. Typically it's 2, you double it. That's another constant value. By previous unit. Yeah. I should say the next unit. Next rather than new. Next seems to make more sense. Why do we have two different scales then? Why does one linear and one logarithmic? Why does that make sense? What do you suppose the lowest is on this scale for income? What's the lowest income?
I'm just going to say the range is just, the two ranges of the scale are just so much different.
Yeah, the ranges are totally different, right? The minimum we're looking at is in the hundreds of dollars. Average income of hundreds of dollars a year. We see Democratic Republic of Congo is 607, for example, in 2009. The maximum is always, does anyone know, by the way, you can see this little tiny dot right here. Does anyone know what country that is? Nope. Close. Qatar. And what's the average income? You see it? We get 123,000 a year. So from way less than 1,000 to way over 100,000. It's a huge range. And we can, if we want, switch this from a log scale to a linear scale and see what happens. That's now a log scale. 20,000, 40,000, 60,000, 80,000, 100,000, etc., etc. Right. Each unit is the same. Is this easy to read though? No, right? We have so many that are so low, they get bunched up right here. You can't really tell differences. And then we have like Qatar and a few other really wealthy countries that throws it off. So when that range is really broad, it's just what does the switch back to a log. Yeah.
Is there any way to find out which job it is in Qatar offers input?
No, that requires more detailed data. All we know is the average income is 123,000. So that's average. In case, in point of reference, the United States looks like 48,000, 48,600. What happens if we switch the life expectancy? Well, that seems so much better. Let's just make the life expectancy low too, right? Because it's just so much better. Here we have life expectancy and logarithmic scale. 1, 2, 4, 8, 16, etc. Doubling each time. Is that better? No, why?
It makes it look easy to draw.
Yeah, it's like almost flat, right? Because while there are differences in life expectancy, those differences are relatively small. And you see that, right? Like some of these pretty high life expectancy in Norway is almost 81. And that's not that much different than United Arab Emirates, which is 75.6. But that's like 5 years. That seems like a pretty good amount of time. And then here on the lower one, Ecuador and Guinea, 58. That's a lot different than the 80s, almost 81. But yet they're not that much different. And then you have a lot of wasted white space. So let's switch that back to the linear. And then that's a little better. That's more informative. So sometimes you want a log function, especially if you have a really big range, and sometimes you want a linear function, especially if the range is relatively small. The outliers too, the crazy outliers like we saw with Qatar, often favor logarithmic function. Anyone have any questions? Okay, so let's work for Excel. I'll show you how to do some of this stuff in Excel. Okay, so if you would for me, go to my website and download dataset 1. Dataset 1. And it should appear there. You're just going to click on it and pull it up. Now, as normal, when you see this, you're going to see the enable editing come up. Click the enable editing so it doesn't get pissed at you as you try to manipulate it. So no, you can't do that. And here we have some country data. These are some of the variables I pulled from the master data set, from the memo data set. Just a few for us to work with, because you don't want to have a whole bunch. It's a bit overwhelming. Also note too, I need to update this. The alcohol consumption, it used to be only 1 decimal place, and now it's 2. I've updated it recently, so it's 2, because the data was updated. So it looks like Afghanistan has literally no one drinking alcohol in it. Really, I think the actual value of that is 0.02. So that's why I was rounded down to 0. Even that said, too, it's probably not even 0.02. It's probably higher than 0.02, but a lot of it goes unreported. Much of this is self-explanatory. If you want descriptions, you can click on this right here at the bottom for descriptions. And it takes you to a different, it tells you what all these variables are. Gives you a nice description of each one of them. Notably, the murders, for example, is not only adjusted for population, it's adjusted for 100,000 people. Because murders are pretty rare, thankfully. So if you did it murders per person, it would be a very, very small number. It would be not intuitive. Murders per 100,000, much easier to understand. Population density, or population per square mile, in relation to population per square mile, or square kilometer. So, if everyone has this data, since we literally just did scatterplots, let's do scatterplots again. Let me show you how to do scatterplots in Excel. It's really easy. Now, as noted, all scatterplots involve 2 variables, an x variable and a y variable. So in order to do the scatterplot, we need 2 variables too. And it's a very common thing I see is that people, when they do their analysis, they want to predict murder rates, and they want to use population density to predict murder rates. So the theory that denser places will have more people stabbing each other. I always imagine stabbing, even though guns are more common, but I always imagine stabbing each other. So let's do a scatterplot. To do a scatterplot, we're just going to highlight G and H. You can also take G1, drag it all the way down to the last observation. That takes a little less. It's nice if we just do G and H. Sometimes you literally have to do it that way to drag it. But. Then we're going to go to Insert. And in the chart section, right here, is scatterplot. You just click that, you do a drop down on here, and you select the first one, and you get scatterplots. Now, whenever Excel does this, it will automatically make the first variable, the one on the left, it will make that your x-axis. And the second variable, the one on the right, it will make your y-axis. It always goes x and then y. Now, that's obviously not clear, so it would be nice if we had some labels. Let's add some labels to this. Does anyone know how to add labels to a chart?
Plus sign?
Yeah, we go to that plus sign over there. You can see the add chart element. If you select it from the drop down, we can add axis titles. So we can add a primary horizontal axis, primary vertical. Let's do that. So first we have to do this individually. It's kind of hard. We can do primary, and this is our murder rate per 100K. It's going to put it right there in that formula bar at top. When I hit enter, it's going to put it right there at the bottom. And then axis title, primary vertical, and we're going to do population density. We can even do if we want. There. Make sure it's clear that it's in kilometers, square kilometers, rather than square miles. And enter again.
What does it say in parentheses?
km2 or square kilometers.
Okay.
But the exact wording doesn't matter. Just I just threw in that information because I think it's nice to have. Now, how do you feel about this diagram? Is it telling you anything? What's your name again? David. Yeah. Oh, we got that issue from before, don't we? So do you know, David, how to fix it? I don't know. Do we know how to fix it? So the fastest way is to select your vertical axis. So click anywhere on here and select it. And then you right click. And you will want to go to Format Axis. And when you select Format Axis, you see all these cool options, but the one you care about is where? Logarithm scale. Oh, makes it so easy. It's so great. Logarithm scale, boom. Just select it. Boom. Logarithm scale. Yeah. So I selected the axis, and then I right-clicked on it. I think you might just be able to right-click.
I'm going to select it first, because I think that's maybe the word I saw. Yeah, and then you just select log with the scale, and you're going to log with the scale.
Do you think we should, so we did it now with population density. Doesn't look like there's a relationship. Do you want to do it with murder rate? We can do the same thing with murder. We can do the same thing. We can make murder rate a logarithm scale too, if you want. Would that be a good thing to do? What do you say? You don't know. It does?
Well, I did it.
You did it.
I did it on
Well, so why is that weird? Let's do it.
It looks like negative.
Oh, so it's, I'll show you how to fix that in a moment.
Oh, okay.
But focus on the dots. So if we right click, we still got format axis activated, so let's say log with the scale. Ignore the fact that this axis moved over. I'll tell you what happened there in a moment. Just appreciate, is this more informative than what it was before, as far as the pattern of the dots? Before it was like this. Which is tricky, right? Because all these things are right here. Just like what we have with the GDP per capita with average income. A lot of information and then a couple weird ones. Very, very murderous places. I wonder what these countries are. Don't go there. So, arguably, a logarithm scale on both sides is quite good, right? You see the spread of the data quite clearly. You instantly, too, note that there really is no relationship between population density and murder rate. But one of the weird things this did is it scooted our axis right here. That's weird. Does anyone know why it did that? Yours? When you made it along with the scale, made the well, it's not along with on the x-axis, made the murder rate longer. So you have to click. No, you click the titles, click the actual numbers. Yeah, and then you right click and format and you see it. So it does that because this is using natural log. And you can see right here, axis, where the vertical axis crosses axis value. It should default to 0. And you see that if you were to undo it, it would default to 0. At least it should. Yeah. See, axis value 0. The problem is the natural log of 0 is undefined. And so Excel, in its great brilliance, gets confused about where to intersect this and then scoots it over to 1. So we can fix that pretty straightforwardly by selecting axis value, not making it automatic, just selecting it. And turning that 1.0, which is sticking it here, to 0.1, which will stick it here. So So saying this vertical axis doesn't intersect at 1, it should intersect at 0.1. Boom, there it is. Much better. Oh, the keyboard doesn't work? Or are you sure the num lock this isn't accurate? Well, that's because you have something selected. Okay. Well, this is okay. That's yeah. Okay. Weird. Any questions on this? Great. I'm going to delete that. I'm going to move on. Let's suppose, too, I'm curious about this BMI male, and I would like to create a histogram with BMI male. There are two ways to do this. The fast and bad way, and the slightly slower but significantly better way. I'm going to first show you the fast and bad way because that's what everyone wants to do. I like BMI male. And if you highlight D, I believe this will work with D. I might have to go back. I might have to highlight D2 all the way down. We'll see how this works. Go to the chart section and select this one in the middle.
Is there the other chart?
Yeah, I just deleted the other chart. I don't want it in my way. And you see there's a histogram actually. You can also do box and whiskers too, which is pretty cool. Yep. Under insert charts, right here in the middle, you see this one inserts the distance chart, and you can insert a histogram. I'm drawing a line too for some reason. Let's just stick with this one. So there's good things and bad things about this. One, it was really fast, right? They're technically done. Maybe we can throw some labels on. But you get this really great picture of what the data looks like. But there's a huge problem with this. What's the problem with doing it this way?
There's no context.
Well, it's supposed to be frequency anyway, so that's okay. It's just the frequency in these different bins, just like before. Yeah, like what the hell's going on here? So it's 19.7871 to, I can't even tell what the other one is. Maybe if I like, there we go. To 21.278 one, and then the 278 to this. This is so awkward and dumb. It does this though because Excel is stupid. Excel is a computer. Excel is a program. I should say Excel is a program. And it doesn't really know that this is not something that's acceptable. This is not easy to read. So it just runs it through an equation and figures out what the bin should be and then walks away. And note too, these bins, it's hard to tell, but these bins are equal size. Right? There's equal distance. About a distance of 1.5. 1.5, yeah. It's just like, it's just weird, it just annoys me. So I recommend doing this just to get a feel for the data, but I would never suggest that you present this, especially since it's auto-generated, it's hard to change these. Instead, we're gonna have to do this the long way. It's not that long though, because it's a computer, it's fast. So, I wanna set this aside though, I'm just gonna put it over here, so I wanna mark this later. In order to do this the better way, you have to define the bins. So what you do is you select the maximum for the first bin. What do you think our maximum for the lowest bin should be, for the smallest one? When that will be this number or less? What's a reasonable minimum bin size? A minimum bin starting value? We can do 19. I did 20. Yeah, I sort of want to do 20. Because like the lowest here is 19.78. So not even 19, right? So I did 20 for mine. 20 is a nice round number. Then, and I just put that anywhere. Then put in the maximum value for the next bin. So we need to figure out how many we're going to increase it. This increased it by 1.5. Each one of these is 1.5. So what do you think we should do? Do 2. Yeah, I do 2 in the notes. You could do 1. You could theoretically do 1.5 if you wanted. There's a little bit of give as to what the quote-unquote right answer is. But for simplicity, I did 2. So we did 2. And 24. And if you don't want to type these out individually, you can just highlight 2 of them and then drag down, and it will automatically project. Right, all the way up to, say, 32. I stop at 32 because you can see things really 10 are off right here in the 30s, in the low 30s. There's like one that's really high, but you never want to want to extend all the way out there for the random weird one. So you want to stop at some reasonable point. I'd say 30. Now, we have our bins. And Excel has a program that lets us take those bins, and it will tell us how many observations are in each bin. We use that table that it will produce for us to make our histogram. Before we do, we need to install a program. And by install a program, I mean tell Excel to activate something that it really should always have activated, but for some reason it doesn't want to activate automatically. You have to do it like manually. It's really annoying. But you'll use this option a lot. To illustrate, so it will be under what the option that will come up will be under data. So I'm only pulling up data so you can see the option come up. But in order to get what's called the analysis tool pack, you have to go to File. Under File, select Options, way down here in the bottom left-hand corner. Then, ignore all this stuff, you want add-ins. You want the add-ins option. And then at the bottom of add-ins, you want to set Go under Manage Excel add-ins. You want to say Go. You ignore all this crap, you just hit Go. And when you do that, you will see the Analysis Toolpack option. There's also Analysis Toolpack VBA. Either one is fine. So we can just select that. And when you select that, hit the check mark and hit OK, you will see a new option appear right here called Data Analysis. This is a really helpful function. It has a lot of the slightly more advanced stuff for Excel. I don't know why they hide it. But if you select data analysis, you see all kinds of cool stuff. Some of this you don't know what it is, some of this we'll cover. But one thing you do see is histogram. So select histogram. This is a window that Excel will display when it wants lots of different things and it wants to tell you more about what it wants. It's just a more advanced version of like the comma thing that we've seen earlier with the functions. You know, we separate the various inputs. The things we care about are input range. In other words, this is where our raw data goes. Our bin range, which are the bins that we described right here. And the output range. So I'm going to select this because for some reason defaults I'm putting in a new worksheet, which I never understood. Just put it on the same thing. Just put it on this worksheet I'm using. You didn't notice other stuff. So for input range, my input is going to be BMI male. I'm going to select from D2 all the way down to D185. Do not select D1. If you select D1, if you include D1 in this range, it will give you an error because it will read the label, the first thing in D1, what it's called, as the data point. And it's like, that's obviously not data, that's just a word. If you want, you can select labels. And in the future, I will encourage you to do that. When you select labels, you would tell Excel that the first row, whatever you highlighted, is a title of whatever it is. In other words, it treats it as not data, but information they can use elsewhere. So you can select labels if you want and include D1. You don't have to though. I'm keeping it off for now. For bin range, let's go back up. And we're going to highlight our bins. In this case, I did it as K3 to K9, but of course you could have started somewhere else. Again, if you selected labels, which you find you can do, but if you do that, make sure to do this highlighting, start one cell above. Because otherwise it will think 20 is not a bin, 20 is the title of whatever you're working with, right? Excel is dumb. It's useful, it's fast, but it's dumb. So, that's why, again, I'm just selecting label, I'm just selecting this, and I'm ignoring the title over there. Finally, select output range. And select this field, and then select a cell somewhere that's blank, in a blank area. This tells Excel where to output the table that you will produce that will show all the different frequencies. It'll be the upper left-hand corner of that table. I selected J12. It's going to expand out this way. It's going to be just right here. There's some blank space there. And I hit OK. Is everyone good? I should have checked to see if everyone had this. Does everyone have this? Yes?
No, not me. For input range, I selected D and 11.
Okay, so you just, if you click right in there, and click next to the 1, and just change that to a 2, so delete and then change. Oh, wait, you wanted to do the labels? Oh, I'm sorry, okay, so go back to 1, and then just select the labels out. And you should get something like this. Does everyone have this? All right. Now things get pretty easy. Highlight the information, skipping over the bin part. And go into Insert. And in the upper left-hand corner, you're going to ask it to insert column or bar chart. Making sure, of course, you highlighted this area. And then just select the very first thing. And now we have a nice, clean bar chart. It's doesn't look quite like this one. We can make it look a bit more like this one, as far as the aesthetics go. But note, our bins are much more intuitive. Any questions?
Is there a shortcut?
What?
A shortcut
To what?
to do add-ins and stuff like that?
No, I mean, the advantage is if you do this on your own computer, like your computer will remember that data analysis is installed. But because of the school's computers, they reset stuff. So that's an annoying thing you just have to deal with this, guys. You get used to it. It's faster. The shortcut is you get used to it, and it just goes by really quickly. Now, this is still not great, because 20 isn't really a great bin, right? Like, we had at least some sort of range here, even though we had to struggle to see it. But the advantage is it's pretty easy to change it if you just select. In my case, it's J13, it looks like. You just select it, and you just start typing. Type in 20 or less. Right? That's what it actually represents, 20 or less. And when you hit Enter, this will update too. And then you can change all of these. So you can do like 22, 22, and 22 to 24. Or if you were like retentive about it, which I'm not judging, but if you're like, well, then you have an overlap of 22. Where does the 22 go? You could change this to 20.01 and 22.01. It's a judgment call on your part. On one hand, it's going to make it look less neat. On the other hand, it is more exact. On the other hand, like how often is someone exactly at 22 BMI average, especially when we go up to 4 decimal points or 5 decimal places. So I don't really mind this for this example, but just so you know, if you're curious, you can do it that way. You can do 24 to 26, or if you want to, you can also even type it out as 26 to 28. So you can do that as well. It's up to you, whatever fits your aesthetic. I'm just showing you all the different things. Because what's nice, again, because you made it yourself, you have complete control over the details. What should we call this last one? Technically, we should call it more than 32. Because we don't technically include 32, so if we have to write something out, we might as well give exacting details. I sort of like that too. I think that looks kind of nice. There we go. I'll make it bigger too. Oops. Grab that. Stupid thing. Okay, every time I grab it, it thinks I'm grabbing something else.
I know.
So you just pull it over and then you just grab it that way.
Yeah, look at the air.
Yeah. You can also, if you want, add labels just like we did by selecting the chart. You know, under design. And under design, you can add chart element. You can add the labels if you want. But do you notice another aesthetic difference between this one and this one?
Spacing.
The spacing, yeah. This is technically like what a lot of histograms do is there's no space between the lines. It helps to distinguish it from a bar graph. So we should technically do that. Super easy to do. Just select the actual data. Like we did right here. I just selected a bar, it doesn't matter which one. I selected the big one, which was faster. And if you right click, where'd it go? Where did my options go? Add data labels. Format data series. And you see if you format the right click and format data series, it gives you an option for gap width. Bring that gap width all the way down to 0. There we go. Now, of course, what we made is not identical to what this is. Why not? Well, okay, we can put in a gap if you're annoyed that there's literally no gap at all. We can put in a gap. That's no big deal. I'll kick it up a little bit. What did you say?
Because you said 22 to 20.
Yeah, I gave us a distance of 2, but this is a distance of 1.5. So again, you see how, like, this looks very different than this. It's a little bit more chaotic here, it looks a little different. I mean, it's the same general pattern, like this is pretty big, this is pretty big. If you want to, you can also make this a bit narrower, just so it doesn't look too overwhelming. But of course, if you wanted to replicate this exactly, but with better labels, you can just make it a 1.5 distance and do 20, 21.5, 23, etc., etc. You will, of course, end up with more bars, just like this one has more bars, because, of course, you're using a smaller unit. Anyone have questions? One last quick, super fast, and I guarantee you it's super fast thing to do, just in case you're curious. If you want to make a pie chart, it is pretty fast. Pie charts are very standard things. You can just highlight this, go into Insert, select that pie chart there, select, and there we go. We're done. And you can format it if you want. You can play around with the options. Right? you sort of see those some of the issues we run into like we did before, right? Some of these values are really small and they're very hard to see.
Say you wanted to print the project.
Ah, I'm glad you brought that up. That's the last thing I forgot to remember to bring it up. If you want to print the pie chart, or if you want to print any chart, select the chart you want to print and press Control-P. When you do that, it will know what you want. Print select a chart, and you can just hit print if you want. But when you do that, make sure you're just selecting the actual chart, you're not selecting anything inside it. Any questions? Yeah. No? No.
No.
I can go back if you want. All right. I'm out of time. So I will see you on Tuesday. Have a great weekend, everyone.